As you might know, periodontitis is associated with a very specific spectrum of bacteria that are progressing and causing the disease. And then there is the keystone pathogen hypothesis that mainly Porphyromonas gingivalis is the driver of the disease and the progression. And what we still do in order to treat it is to remove all bacteria from the biofilm, from the microbiome, which is causative of sure, because you get to reduce the bacteria, and therefore you hope you reduce the inflammation, which is the leading cause for periodontitis, but it comes with some side effects. So you kill the entire microbiome. However, you have good bacteria, commensals in there that do have a function. And what you are also doing is you allow uncontrolled growth in an already irritated, inflamed tissue, and you do risk gum damage. So what we did at PerioTrap is we developed a selective pathoblocker that selectively targets and blocks Porphyromonas gingivalis, Tannerella forsythia, I learned this today, thank you for the thrilling story, and Prevotella intermedia. And so we have developed a compound internally dubbed as 636, so that was number 636, which is a small molecule de novo designed to selectively target an enzyme in these three bacteria that mingles with their metabolism. So they're less vital, less toxic. We reduce their virulence. Virulence factors are being reduced. We see no systemic uptake of the molecule. We see no toxicity towards human cell lines. We see no antibiotic effects towards the mentioned bacteria. And when we look into in vitro assays, what we do see is a reduced tissue invasion of Porphyromonas gingivalis into keratinocytes. And we were looking into a 12-strain artificial biofilm. What we see is a reduction of biofilm mass, even though it's just the three bacteria that we're addressing, and their activity. And if we put the biofilm onto macrophages, we also have a 95% reduction of macrophage reaction of it. So this data was old. I showed it last year on a poster. And what we accomplished until then is we registered our products as cosmetics in the European Union in June. We developed a dental gel, which is then supposed to be applied after the cleaning and the SRP, both of them. And it's one system together with the toothpaste that should sustain the effects of the dental gel after the treatment of you professionals here. And we collaborate with EMS with it. We show their logo. This was a development from a biotech company developing initially compounds against diabetes. Januvia is the background of these DPP-4 inhibitors from Uli. And then in 2008, Jan Potempa, you might know him, University of Louisville, he found that Porphyromonas gingivalis exhibited the gene or the target we're addressing. And Uli was back then looking into the target in Alzheimer's disease. So the molecule you have in your hands in these products initially comes from Alzheimer's research. And this is a classic thing, what you do in biotech. You look, where is that target? How can it function? Does it work in other indications as well?